So what are you presenting here?
We're presenting a patented innovative technology that augments the sensitivity of a capacitive screen in 3D. It enables a new user interface, very natural, with multi-touchless and gesture recognition and without touching. So it's not camera based, it's based on electrostatic fields. So it works at night, it works whatever the lightning conditions are. So you can select, push, you can rotate and make some rotations, and you can think of any kinds of applications in the gaming industry. For instance, if you have a stereoscopic 3D screen, you can play with the projected image. You can do like modeling clay on the projected image. So here it's photo album applications, and we have as well some handwriting applications, which is just on the next demo. Allez, handwriting. So here, for example, we pick up any kind of number and we draw on it without touching. Erase, draw. So we can make complex shape and totally recognize them without touching. So it's multi-touch, multi-touchless, gesture recognition and approach detection, all in one technology.
What do you say, multi-touch? Like, will it...
Yeah, not here. Here is only the gesture recognition demo, but the technology allows multi-touch and multi-touchless.
Is it an app? The app needs to do it, or this demo doesn't have it?
No, this demo doesn't have it, but the technology can do that.
So, do you have a drawing showing a little bit?
Yes, on that.
So this is a technology?
Yeah.
So what is going on there? Is it only... There's a field going like this?
Yes, there's an electrostatic field on top.
Going everywhere?
Going about like a dome, about like a big circle around.
Only from one side to the other, not 360 degrees?
Yes, 360 degrees.
Okay.
On billions also.
Yeah.
So for instance, you start with the touch, standard touch technology, multi-touch. Then you can do hover, picking, rotating, zooming in, zooming out, multi-touch. Then you go up about 3 centimeters to do hover. So 3 centimeters above you can do multi-touchless. Then gesture recognition and then approach detection.
Nice.
Nice and easy, very low cost.
What's going on in there?
So
there's
so you have peripheral electrodes that equip your standard tablet.
So where are they?
They are on the periphery, of the screen. It's
part of the bezel.
Part of the bezel.
Part of the. Could you put it in any tablet?
Yeah, or on telephone.
So it could go.
Yeah.
Around here.
It can go around here, absolutely.
Yeah.
Yeah.
And it would just work.
Yeah.
But how much do you need to add to it for it to work? How much?
Nothing much. It's an 8-bit microcontroller to acquire the data, and then we use the microcontroller of the tablet to extrapolate the data into the gesture recognition and multi-touchless.
So you need to put some power in there to make the field, right?
No, it's very low consumption.
Yeah.
It's less than 2 milliamperes, and we just do the scan rate according to the application. So when nothing is in the field, the scan rate is just to just to verify nothing is happening. And when something is happening, then we do a scan rate very much quicker to make sure that we follow the gesture.
Nice. And touch as well. So everything is...
Yeah, but here we deactivated the touch. We just show the gesture recognition.
So if you can add it to any other touch technology, you can add it to capacitive.
Yeah.
Add it to IR touch.
Yeah.
Add it to resistive.
It's capacitive. On here it may be a hybrid solution with a resistive.
Resistive.
With a low-cost resistive, very low-cost
Yeah.
solution for gaming console for example.
But you can do with capacitive as well?
Yeah.
Yes.
And so basically it's just extra technology.
Yeah.
It's not instead.
Oh, it can be instead. You have 2 ways of doing it. You have the hybrid way, where we leave the touch technology as it stands in a normal tablet, and we're adding some peripheral electrodes to bring new functionalities like multi-touchless and gesture recognition. Or we can replace the existing touch technology, and then our technology does it all. Touch, multi-touch, multi-touchless, gesture recognition, and approach detection.
So you have some vision as well of adding your technology into robots?
Yes, we believe it could be a much more natural user interface where, for instance, a robotic creature, a companion, could sense when you're arriving from the back or from the side, instead of looking at you just only when you're in front of the camera. He can sense your arrival and then turn his head towards you, for instance. Or he can know whether you slap him violently or you just caress him to be gentle.
Nice.
Because pressure touch we do as well.
So the refresh rate can be very fast.
Yeah.
Depends on the microchip.
It depends on the microcontroller.
Microcontroller.
Yeah.
And since when do you have this technology?
So we started developing it about 2 years ago, and we are building new demonstrators every day, and we are stabilizing this technology.
New demonstrators, what does that mean?
Well, new, applications, use case, scenarios, and it's the first time we show it on a tablet. Actually.
First time you show it.
On a tablet, yes.
So next year it's going to be in every tablet?
Next year it's going to be on a stereoscopic tablet, probably.
Stereoscopic.
A stereoscopic, the 3D image, and then you can interact with the image that is projected directly with your fingers and your hand. Like modeling clay, for instance, you could model, or in a Nintendo 3DS, instead of petting your dog with a stilet on the lower screen, you could pet your dog directly by putting your finger on the upper screen.
All right. How much does it cost?
It costs very few things because it's a very small microcontroller. It's a few electrodes in copper bands, for instance, and it's a very small microcontroller. And then it's a cost of a license, and it depends of the proprietary technology, and it depends of the quantities, countries, and who the partner is.